Grokking signed overflows, detecting an overflow when adding two signed numbers. Before moving on to overflows, it's important to understand a bit about how signed numbers are represented in binary. When a number is signed, the high bit represents the opposite of what it typically would. For instance, if we look at a 4-bit signed nibble, instead of the high bit representing 8, with a signed number it would represent -8. With our 4-bit signed nibble, 7 is the highest positive number that we can represent. If we set all three of the positive bits in the 4-bit nibble, we're adding 4 plus 2 plus 1, which represents 7. If we set the -8 place only, we get the lowest negative integer our nibble can represent, which is -8 plus 0 4s plus 0 2s plus 0 1s, or -8. Now, if we set the -8 place and the 1 place, when we add 1 to -8, we get a total of -7. With our theoretical 4-bit signed nibble, we can represent all integers from -8 to +7. There are still only 16 bit patterns that we can represent in 4 bits. 8 of them represent numbers that are negative, and 8 of them represent numbers that are not negative. Because of how the numbers are arranged, a computer processor can do binary addition without needing to know whether the two numbers it's adding are signed or unsigned. The resulting bit pattern will be the same regardless. It's all about the interpretation. Now that we grok how signed numbers are represented in binary, we can move on to discussing signed overflows. When adding two numbers with a different sign bit, the sum will never overflow. Sums will only overflow when both add-ins have the same sign bit. When adding two signed positive numbers, if the sign bit of the sum is set, an overflow has occurred. We know that adding two positive numbers cannot result in a sum with a negative sign. Likewise, when adding two negative numbers, if the sign bit of the sum is not set, an overflow has occurred. Adding two negative numbers cannot result in a positive number. Detecting an overflow is only relevant when adding signed numbers. When adding unsigned numbers, we needn't concern ourselves with the most significant bit of the sum.